This lesson is 12.1, Explore Solids. So before you identified polygons, and now what we're going to do is we're going to identify solids. So the key vocabulary you should have already defined in your notes or on the paper that you printed off. So if you have not printed off that paper, you need to pause the video at this time, go into your Aries account, and print those two worksheets off. So a polyhedron is a solid that is bound by polygons. These polygons are called faces. So right here I have this here is a face. This also here is a face. So the next thing that's important is the edges. So the edges are just line segments that connect the faces together. So these are edges. And then the last part of the polyhedron are the vertices. So the vertex, this is a vertex, and a vertex is when you have three or more edges where they meet. Plural for polyhedron is polyhedra or polyhedrons. Here are your vocabulary words. If you have not defined them, please stop the video at this time and please put them on the piece of paper that you had printed off. So a polyhedron is a solid bounded by polygons. So you can see polyhedra right here. This here is a prism polyhedra, and this is one of the faces right here. Here's another face. So here's a face on this side. So this is a prism polyhedra. So those are all polygons. This one here is a pyramid, and you're going to learn more about these further into the chapters. So these are both polygons, made up of polygons. Now, these are not polyhedrons. So, because they are made up of circles. Okay, so a circle, you know, is not a polygon. So when you classify a polyhedron, you always look at what its base is, and you name it by its base. So the bases, so on this one here is my base, and how I can tell what the bases are is that the bases are always parallel to each other, and they're the same, the figures are congruent. So this pentagon here is parallel to that one, and it's congruent. They're exactly the same. So that's how I know what the base is. So this is a pentagonal prism. This one over here is a pyramid, and the base here is a triangle. So this is a triangular pyramid. So you name them by their base. So this is on your worksheet that you should have printed out. It says tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. So our first one we're going to look at, A. I can see that this is a polyhedron. It has 4 faces. So it's a tetrahedron. It has 4 vertices and 6 edges. So remember, the edges are like right along. So there's 3, 4, 5, 6. So that's the edges. The faces. So 1, 2, 3, and then the back one is 4. And then the vertices are just where they come together. 1, 2, 3, 4. So those are the vertices. Now the next one, B, is a polyhedron, and again the bases here are hexagons. So here is, and they're parallel. So here's the other hexagon down here. They're parallel and they're congruent. So this one has 12 faces, 8 faces, 12 vertices, and 18 edges. Now the last one is not a polyhedron because the solid has a curved side. So this one is not a polyhedron. One important thing with this section is Euler's theorem. So we know Euler, he developed this idea, and he said if I know how many faces there are, vertices and edges, and if I'm missing one of them, I can solve for one. So he developed the F faces plus vertices equals edges plus 2. And in your example right over here, we have the faces as 6, the vertices as 8, and the edges is 2. So 8 plus 6 is 14, is equal to 14. So this is the idea that he developed. So looking at my little example right down here, I can go ahead and solve for one of the missing sides. So let's say if we're going to solve for edges, so I always write the formula first. So I'm going to say F plus V equals E plus 2. So my faces, here's 1, 2, 3, 4, and then 5, the front one. So faces is 5, vertices 1, 2, 3, 4, 5. And then edges is what I'm solving for. So this is 10 is equal to E plus 2. So if I move my 2 to the other side, I should have 8 edges. So 1, 2, 3, 4, 5, 6, 7, and 8. And yeah, it checked out. So Euler's theorem is important. So let's just do a practice. Let's do number 11 first of all. We're going to do this one right here. So always start off by writing your formula. So now I have my faces is n. So n plus 12 equals 18 plus 2. N plus 12 equals 20. Subtract 12, subtract 12. So therefore n is equal to 8. So I'm just going to substitute it in and check it. So 8 plus 12 equals 18 plus 2. So that checks. So let's just do one more. So let's do number 12. So once again, start off by writing your formula every single time. So F is 5, V is n, 8 plus 2. So 5 plus n equals 10. Subtract the 5. And that gives me n is equal to 5. Let's just substitute it back in to check it. 5 plus 5 equals 8 plus 2. Yeah, that is equal to 10 plus 10. All right, you pause the video right now, write this down, and just do one more check. And then once you have it, start the video again. So now that you've started the video again, you should have came up with n is equal to 24. So that's the answer to that one. All right. Here is the second example on your note sheet. So therefore you had, on this one you had to go through and count all the faces, all the vertices and all the edges, and then they just ask you to substitute it in. All right, so convex, concave. So that term you're familiar with. We learned it back in chapter 1 or so. So a polyhedron is regular if all the faces are congruent, regular polygons. So regular just means all of them congruent. A polyhedron is convex if Any 2 points on its surface can be connected by a segment that lies entirely inside or on the polyhedron. So you can see this lies along the polyhedron, so that line. This one here lies along it, stays on it. Now, as you can see over here, this one does not. So this one is concave. So we call that one concave. It is not touching right through here. It's not touching the polyhedron. So that one we call concave. Platonic solids they're 5 regular polyhedras. That means they're made up of the same shape. So the first one is a regular tetrahedron. So it has 4 faces, and it's made up of regular triangles. The second one here is a cube. It has 6 faces. It's made up of cubes. The octahedron has 8 faces. It's made up of triangles. The dodecahedron has 12 faces, and you can see it's made up of pentagons. And this is kind of like what a soccer ball is. And then the last one is a icosahedron. So your assignment that you need to bring in tomorrow with you to class is you're going to go to this website right here. Math is fun, and you're going to click. You're going to find the platonic solids, and you are going to print off one of the nets. Is what you're going to do. So let's just kind of look at this this website right now. So there's here is the tetrahedron. There's the cube. Here's the octahedron, the dodecahedron, the icosahedron. So you can kind of see all the information here. It's made up of 5 triangles meet at each vertex. It has 20 faces. It has 12 vertices, 30 edges. So let's look at the net that you're going to print off. So we're going to do it with tabs. So you're just going to print this off, and then you're going to glue them together. So I don't care which one you do. Another way is to click on this button right here, and it's going to take you to just the nets themselves, so you can choose one and print them off that way as well. So we want to look at them animated. Once you print it off, here it is animated. There's a print button right there for the net. So it's just kind of a fun thing. So you will be graded on this tomorrow. So if you do not bring this in, you will not get credit for this assignment. All right, let's go back to the lesson. All right, again, you're going to turn this in class. All right, there it is again. That's just the nets. Okay, next thing is cross-section. Today in the video we looked at Spherius, and he had a cross-section, and we said his cross-section was a circle. So if I'm looking at the cross-section in my pyramid right here, I can see that the cross-section of the pyramid is just a triangle. So here I have in your examples, I have 3 cross sections, A, B, and C. So here's Spherius right here. Let's just put little eyes on him. Yay, he's like a happy guy. All right, so and we can see that his cross section is a circle. So the cross section on A is a circle. On B, here's the cross section. Hopefully you already wrote it down. It's a pentagon. And then the last one, here's on my cylinder here, the cross section is a rectangle. All right, so you're going to stop the video and you're going to complete the checkpoint. When finished, you're going to check your answers. So stop the video at this time, complete it. And so you have turned the video back on. Hopefully you did stop it, just because you need to check your understanding. If you have questions, you need to write those questions down. And then you need to bring them to class with you. So there's the cross sections. And that is it. Thank you. And see you in the morning or in the afternoon.